Welcome to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle and I'm here with my co-host Eric Heim. As you can see, it's our annual beach episode coming to you from Newburyport on Plum Island. And you know, Eric, there's been a lot of shark sightings this year, especially on the East Coast. And next week is Shark Week. So I thought we'd take a look at the wireless technology that's used to track them. So they use a tag called SPOT. It's Smart Position or Temperature Transmitting Tags. And for the shark, it goes on their dorsal fin with an external antenna. And when the shark comes above the surface, the antenna is able to transmit geolocation data to the Argos satellite array. And that's how they're tracked. And of course, there's an app for that. So I downloaded the OSearch app, and I'm tracking about 4 or 5 sharks in this area. So if you catch one with a fishing pole, I'm not taking it off. So this episode, we're going to cover our July software and design issue. And in that issue, the cover story is Enhancing Sub-Terahertz RF EDA Workflow for 6G Challenges, written by Keysight and Strataset. And so it gets very complicated over millimeter wave for the EDA workflow, so they look at simplifying it for the future for 6G. What did you see for technical features?
Well, first of all, we're going to stay away from the sharks. But speaking of sensors, we had a good article from Cognitive Systems where they're talking about their Wi-Fi motion system. And what they point out in the article is that the average household has 22 Wi-Fi enabled devices. So with a combination of multipath and time domain and that sort of thing, they're able to come up with a network that will sense when people are in the house. And the article goes into a lot of detail on the math and some of the processing that allows them to be able to determine exactly what's going on with that object that they've detected. So that's part of this emerging Wi-Fi sensing market, and it looks like it will hold good things for that in-home care, that home monitoring, and smart home applications. So that's interesting. I'd definitely take a read at that. In addition, since this is the software and design issue, we had a great article from DGS Associates where the author takes us through a number of designs and optimizations for SMT-based filters. So lots of charts, lots of graphs, and at the end there's actually an appendix where the author takes us through step by step, actually doing the analysis for one of these filters on a Cadence software process. So for the folks that like that sort of design, great article.
So we had a couple guests join us remotely today. Kai Lowe and David Kiesling from Times Microwave Systems joined us to talk about cable assemblies for space applications. So let's take a look at a clip from that now.
So what are some of the different types of RF cable assemblies that are available for space applications?
So traditionally, we're using more PTFE-based cables adapted to the environment, but the most common cable we're selling today are our phase track family of cables. So the same types of requirements you have on the terrestrial side, multi-element antenna arrays and so forth, and the phase criticality that you have to maintain to make sure your antennas and communication systems work accurately apply there as well. It's actually even more stringent because, you know, you imagine you're a little tiny spacecraft way up there. You know, there's no room for error when you're trying to pencil in on that antenna up there. So the phase track materials meet the requirements for being in space for all the different things that Kai mentioned, outgassing and so on, and they provide the phase stability over a very broad temperature range. Because that's something we haven't really mentioned. You think about going around the Earth, you're going to be in sun, and then you're going to be in dark, deep space. And the temperature range you see when you do that is really severe. So it's not like it just gets a little cool, right? It gets really cold. And so you want to maintain that performance across that temperature range as well as all the other things that we mentioned before.
So it's really interesting to learn about the key performance parameters for cable assemblies for space applications. It's really a lot goes into that. So turning to the news, Menlo Micro announced that they have acquired assets to build their own fab in Tompkins County, New York. They're going to invest $50 million in the next 3 years and create over 100 jobs in the next 5 years. And they're going to have future expansion plans as they grow. And so that's in our old stomping grounds. You know, you and I from Cornell, when we go back for an alumni visit, we can pop in on them.
Road trip.
And so there was also a few acquisitions I wanted to cover. Abracon says that they will acquire NEL frequency controls. And also BAE Australia said they're going to acquire Radio Frequency Systems Australia. And that's because their German subsidiary is rolling out the defense businesses and just going commercial. What did you see in the news?
Well, I caught one news article that I think might fly a bit under the radar. The MIIT in China announced that China is the first country to actually set aside the allocated frequency bands in the 6 gigahertz range for 5G and 6G. And so why is that important? Everyone has been talking about that for a while, but I think that might be like the flare that gets sent up before the big fireworks goes off, where I think that might be China saying we're about to start looking seriously at 6 gigahertz for 5G and 6G. And if that is the case, then that'll be a land rush as everyone tries to settle on frequency ranges and starts doing the manufacturing, et cetera. So more to follow on that one. The other one that I saw was Keysight updated their PathWave design software. And I think that that gives now the design community around the world a very powerful updated tool, EDA software, and a lot of other tools. And I think that really underscores some of the trends that we saw at IMS. So here's an announcement post-IMS, but it's that same sort of thing. A lot of activity being done at the EDA companies, the test and measurement companies. So lots of activity in that area.
And so turning to events, I will be visiting the IEEE EMC SIPI event in Cedar Rapids at the end of the month. So it's both for Microwave Journal and Signal Integrity Journal, so we get a lot of content out of that. So I'll be posting something online in early August for that.
Yeah, good. And a little closer to home, EDICon will run every Wednesday in October, covering topics in RF, microwave, signal integrity, power integrity, and EMI, EMC. And you can get continuing education credits from IEEE if you watch those sessions online. So book those and put those into your calendar to watch those. And that closes this edition of Frequency Matters. I'd like to thank our sponsors, RFMW and Times Microwave Systems. RFMW is a technical distributor of RF and microwave components and now power components. So when you start your next design, take a look at their broad portfolio of products. And Times Microwave Systems, a member of the Amphenol North America Military Group, a pioneering brand and innovative solution provider for interconnect solutions, cables, and connectors. And remember that as a member of the industry, a subscription to Microwave Journal is free. So please go to our website and sign up today if you're not already a reader. And thank you for watching. And please join us again for the next Frequency Matters.
So we had a couple guests join us from...
We got a lot of guests joining us.